It is given in the problem that there are 2 points A and B of a uniform ring whose resistance is R. So he is saying that there is a ring whose entire resistance is R, which is having 2 points A and B. Angle ABC is theta, where C is the center of the ring. So this is C. This angle is equal to theta. That's what is being given. What's the equivalent resistance between the points A and B? So you need to understand that the entire ring is divided into 2 parts. AB is one part, the upper part is the other part, where the angle between them is equal to theta. So you can say that it is like, we can say the ring is divided into 2 parts, that is AB part and above part, and that means there are 2 resistors. These 2 resistors are in series. These 2 resistors are in, they are not in series, I have missed it. It is in parallel. So if you observe the diagram, if you call the lower part resistance as R1, upper part resistance as an R2, R1 is parallel to R2, the entire resistance between the points A and B is effective resistance of R1 and R2, that is R1 R2 divided by R1 plus R2. So we need to find out what is the resistance to the part of the wire AB. This R1 is how much, we have to find out. This R2 is how much, we have to find out. Let's try to find it out. It is given that ring having angle 2 pi at center at C has resistance R. So question, so resistance for unit angle, for 2 pi resistance is R, for unit angle R, for 1 radian could be R by 2 pi. Then R for theta radian, that is R1, is how much? For 1 radian 2 pi, for 2 radian into 2, for 3 radian into 3, for theta radian into 3 into theta. Similarly, R2 will be careful, the total angle is theta. If the lower angle is theta, total angle is 2 pi, so the upper angle will be remaining angle of that theta, 2 pi minus theta. So R2 will be R by 2 pi and the respective remaining angle on the top, that's 2 pi minus theta. And as it is shown, R1 and R2 are in parallel, and we have to find out the effective resistance of that R1 and R2. Let's try to find out. RAB is, as I have written earlier itself, R1 R2 by R1 plus R2. R1 is this angle whose value is this much, that is R by 2 pi into theta. R2 is this resistance whose value is this much, R by 2 pi minus theta, by R1 plus R2, that is R by 2 pi of theta plus R by 2 pi of 2 pi minus theta. So if I try to simplify that, R by 2 pi and R by 2 pi in the numerator whole square into theta into 2 pi minus theta by I can take r by 2 pi common here. Here is theta. Here is 2 pi minus theta. So if you notice little carefully, this theta and this theta are same. So that can be cancelled. This is r by 2 pi in the denominator. R by 2 pi whole square in the numerator. Therefore r by 2 pi also can be cancelled. So what is remaining? That's equal to 1 r by 2 pi is remaining in the numerator because out of the whole square 1 is got cancelled. Theta 2 pi minus theta divided by 2 pi. That's what remaining is. So if you rearrange the terms, resistance between the points AB is R by 2 pi and 2 pi. This 2 pi comes to the denominator. Here is another 2 pi. 4 pi square theta and 2 pi minus theta is the effective resistance between the 2 points of a ring. That's how we have to solve the problem. That's it.